Our next lesson is on copying and bisecting angles and segments. And just like our last lesson, we'll do most of this during class. But to prepare you for that, to make the most of our face-to-face time, I've prepared this video. In this lesson, we'll address two CCRSM or College and Career Readiness Standards. The first is to know the precise definitions of angle and perpendicular line based on the undefined notions of point, line, distance along a line, and distance around a circular arc. These two definitions will be given to you during this video, and so please pay attention to those as they're given to you. The second standard is to make formal geometric constructions with a variety of tools and methods. We'll focus mostly on compass and straight edge, and we'll be copying a segment and copying an angle, bisecting a segment, bisecting an angle, and constructing perpendicular lines, including the perpendicular bisector of a line segment. Now, there's two words here I want to focus on. First is bisect. Bi means two, and sect means cut. So to bisect something means to cut in two or to cut in two equal pieces. When you bisect a segment, you cut it in half. When you bisect an angle, you cut it in half. And the second word is perpendicular. Okay, perpendicular lines are those that meet at 90-degree angles, and I'll give you the precise definition later on in this video. But those are two different ideas, to cut something in half and to be perpendicular. Every year I have students who are confused by the term perpendicular bisector because it does both. It's both perpendicular and it bisects a segment. But know that those are two separate ideas that are both in the idea of a perpendicular bisector. As always, you should have your student materials with you. We will leave this opening exercise to be done during class. And we'll start with some discussion on some vocabulary words. Okay, copy this down. An angle is the union of two non-collinear rays with the same endpoint. Here's a picture. So here's one ray with an endpoint. It goes on forever in one direction. And then a non-collinear, so not on the same line, ray, but it has the same endpoint. Now, I know that you know what an angle is, but here's a precise definition of what an angle is. Now, I will also put a star and ask you to put a star by this definition. This is in the standards. You will need to know this precise definition because it's part of our standards. The next word is interior, meaning the interior of an angle. The interior of angle BAC is the set of points in the intersection of the half plane of line AC that contains B and the half plane of line AB that contains point C. Now I think we need a picture for that. Here's an angle, and this is angle BAC. Now, by the way, the middle point when you name an angle is the vertex of that angle, the middle letter. So angle BAC goes from B, vertex at A, and then to C. Now, the interior of BAC is the intersection, so where they overlap, of the half plane of AC. So here is line AC. The half plane of AC that contains B. So we're going above this blue line. And the half plane of line AB. So here is line AB. And here's the half plane that contains C. So it's towards the right on this picture. And the intersection of those two half planes is this, or all the points that are in that intersection. So I know that you know what the interior is, but this is a very precise definition for what the interior of an angle is. The definition continues. The interior is easy to identify because it is always the smaller region of the two regions defined by the angle, the region that is convex. The other region is called the exterior of the angle. So this part in red, the other part is the exterior of the angle. Okay, moving on to angle bisector. If C is in the interior of angle AOB, if C is in the interior of angle AOB, and the measure of AOC is equal to the measure of COB, again, here's a picture. This is AOB. So here's A, O, the middle letter is the vertex, and B. If C is on the interior of angle AOB, and the measure of AOC, this angle, is equal to the measure of angle COB, this angle, those are the same, then ray OC bisects angle AOB, and OC is called the bisector of angle AOB. When we say the measure of AOC is equal to the measure of COB, we mean that the angle measures are equal. Okay, so there are three pretty important definitions that'll be useful for you in this lesson. On the next page, there are some assumptions about measuring angles that I wanted to highlight. The first says, to every angle AOB, there corresponds a quantity of the measure of angle AOB called the degree or measure of the angle, so that the measure is between 0 and 180 degrees. Okay, we'll talk a little bit later in this video about how to find that measure or degree, but just for now, know that there is one. The second point is that if C is a point on the interior of angle AOB, so here is C on the interior of angle AOB, then the measure of AOC plus the measure of AOB is equal to the measure of AOB. Okay, so that if you have some angle in between, that you can add the angles together and get the whole angle. The next idea is about a linear pair. A linear pair are two angles that make a straight line. So this is an example of a linear pair. Okay, the last one, number 4, says let ray OB be a ray on the edge of the half plane of H. So here is a line with the half plane above it. Let's say here's H. And OB is a ray on that half plane. For every R such that from 0 to 180, there's exactly one ray OA with A in H such that the measure of AOB is equal to R degrees. So if there's some, for every, there's A, and this is R degrees. Now, the point of that I want to bring up is that the measure of angle AOB is equal to the absolute value of the degree of one ray to the degree of the other ray. So for every ray, there is a degree. If you find the difference between those, that'll give you the measure of the angle. So for example, we're used to working with this being 0 degrees. So if ray OA has an angle of, let's say, 60 degrees, and ray OB has an angle of, let's say, 140 degrees, then the measure of angle AOB in this picture will be the absolute value of 140 minus 60, which is equal to 80 degrees. Okay, we will spend most of our time in class looking at how to bisect. And so let's jump down to the next, let's do some vocabulary. Very quickly, midpoint is the point in the middle. Okay, it's the midpoint of AC. B is in the midpoint if the distance from AB is the same as BC. So the midpoint is the point in the middle. Degree is if you subdivide the length around a circle to be 360, 360 little arcs, then the central angle of that is 1 degree. In other words, if the whole circle, is broken up into 1 degree increments. Okay, 0 angle is if they are exactly the same, and so your measure is 0. And a straight angle is when they're going in opposite directions and you have a straight line. Straight angle is straight line. Okay, let's go on to the next lesson. Lesson 4 about constructing perpendicular bisectors. Again, those are 2 separate ideas. And the only idea I want to highlight here are these definitions at the very, very end. Okay, a right angle is an angle with measure of 90 degrees. Okay, perpendicular, put a star next to this one, that's part of our standards. Okay, 2 lines are perpendicular if they intersect in one point and if any of the angles formed by the intersection of the lines is 90 degrees or a right angle. 2 segments or rays are perpendicular if the lines containing them are perpendicular lines. Here is a picture to illustrate that. So here is one line, here is another line. They intersect at one point. And if any angle formed by the intersection of the lines, so any point here and any point here, forms a 90-degree angle. Okay, and they're perpendicular lines. Okay, the last line is equidistant. Equi means equal, and distant means distance. So equidistant means equal distance. In this video, you were given the precise definitions of angle and perpendicular line. Make sure you memorize those and be very familiar with those definitions. And we'll talk more in class about how to copy a segment, copy an angle, bisect a segment, bisect an angle, and construct perpendicular lines. Thank you for watching.